And let us assume apply the same thing to a galaxy or our Milky Way. In this situation also, the holding pressure is something which we will not talk about, because again it is holding pressure. There is no speed imparted to the stars. So, since this is a complex system, let us study the mass distribution in a galaxy. We know for sure that the galaxy is made up of a supermassive black hole in the center. Then you have an inner ring wherein the stars are densely packed, and then you have spiral arms around it where the stars are sparsely concentrated. So, let us study the galaxy's mass distribution. So, you have a supermassive black hole which weighs as much as 40 million suns, and then you have an inner ring wherein the blue dots represent the stars in the inner ring, and they are forming the inner ring, and the gray dots are the ones which are forming the spiral arms. Now, let us try and understand how this velocity curve is explained by Spacity. Let us first take the inner ring. In the inner ring, as you move away from the center of the galaxy, as the radius increases, you can see that the mass in that particular circumference or at that radius is increasing. And since S3 space force is a force that is acting along the direction of the motion of the masses, also increases. And since S3 increases or the force increases, the speed of these stars also increases. That is how you have this graph which is increasing as you move away from the center of the galaxy. Now, let us see what is happening to the spiral arm. You see, the mass was increasing here in the inner ring, but the masses, the cumulative masses of the stars in that particular radius, as you move away from the center of the galaxy, remains constant. Since the mass is remaining constant, S3, which is directly proportional to the mass of the masses which are making up the system, the S3 also remains constant. That is how you see this S3 remaining constant. Since when S3 remains constant, the speed also remains constant. That is the speed that we see here. The next is at the junction of the inner ring and the spiral arm, these stars, they are not falling back. Why would that reason be? Because there is a play of S2. Like we saw here S3, there is a play of force of S2. That means inner ring is acting as a primary mass and the stars in the spiral arm acting as secondary masses. So, as you move away from the center of the galaxy, S2 is directly proportional to the main mass and the smaller mass and inversely proportional to the distance, and hence S2 is also decreasing. Since S2 is decreasing, the speed is also decreasing. And as you see, if the effect of S2 is decreasing and effect of S3 is remaining constant, this would in a way lead to these stars falling back. That is how spiral arms form. And why does this not drop? It is because this star speed is almost the same speed of all the stars that are there on the perimeter because of the closest distance. So, the basic speed of all these stars in the spiral arm would be the speed of the stars on the edge of this perimeter. And then coming to the effect of the supermassive black hole, we see that it has a minimal effect because on one side you have primary mass which is 1, whereas the stars on the other side is 100,000. Even if you want to take only one sector, it is 25,000. And even if you wish to consider this as a 40 million suns and one star only, this one star on the other side is affected or acted upon by 25,000 ratio. So, 1 is to 25,000, and hence the effect of black hole as such on all the stars in the galaxy is minimal effect. and that is why you will see that there would be S2, but it would be very close to the x axis, just parallel. It would be reducing as you move away from the center, but it would be very less. So, as we saw here in explanation of S1, S2, S3, did we come across anything called as dark matter? No, we did not have to resort to any dark matter, and hence Spacity is able to explain the contradiction that was there in the classical model of universe this way.